Hello again. So far we have learned about motion in one dimension. In this session we will look at a situation where a particle moves in two dimensions. Now before we study this, I would advise you to practice a lot of problems on one-dimensional motion, then and only then watch further videos on two-dimensional motion and tackle that problems. Right. So let's start with a simple problem. Say it is given that a particle which is originally at origin, so I hope you know that there are two axes, x and y axis, which are perpendicular to each other, and their point of intersection is called origin. So we are given that a particle which is initially at origin starts to move such that its initial velocity along x is 5 meter per second, its acceleration along x is 2 meter per second square, and you're given that along y-axis it moves with a constant speed of 10 meter per second. So in the problem we have a particle which is moving such that when it starts to move from origin along x, it has an initial velocity of 5 meter per second and it has an acceleration of 2 meter per second square along x. And for the motion along y, it maintains a constant speed of 10 meter per second. Additionally, it is given, see these are vectors, right? So they need to have direction. So it is given to you that this motion is along positive x-axis and this is also along positive y-axis. Because along x, there are two directions to move. You can go rightwards or leftwards. Right. So, given these values, we have to find the position of particle, at t equal to 10 seconds. Right. So after 10 seconds, we have to locate the position of this particle. When we know that at t equal to 0, the particle was at origin. Right. Now, how should we do this? Here we see we are given variables which are in two different dimensions. Now, before we go there, let's briefly discuss the idea of dimensions. So, you must have heard that we live in a three-dimensional space. Now, what are dimensions? So, dimensions are basically, you could say, variables which are completely independent of each other. So, when we say that we live in a three-dimensional world, that means that to locate a particle, we need at least three variables. Think about it. Say someone is standing in a room. So in this room, if we are to locate its position, how can we do that? We can take references. For instance, we can say that let's take this point as reference, and then to specify its position, you can say that it is, say, x distance on this line, then y distance along the other line, and then at a height of z. So it would look something like this, that to reach that point you have to move x amount on this line, then y amount parallel to the other line, and finally an amount of z along the third line. So since we require at least three variables to be able to uniquely locate a particle, that is why we say we live in a three-dimensional world. Now in this case, we are calling this motion two-dimensional because there are two variables involved. But when we call them two dimensions, it basically means that this is completely independent of the second dimension, and that is the only reason they are independent dimensions. For instance, x and 3x. Look at these two. Look at these two variables. You see that as x changes, 3x would change accordingly. So these two variables are dependent, right? As x changes, 3x would change accordingly. But when we say that x and y are different dimensions, what we mean is that any change in x, any change which is made purely along x, will not have any effect along y. So this is the idea behind dimensions. So when we are saying that we have a two-dimensional motion, that means we have two completely independent motions which are taking place. But the result of that is a single path traced by this particle. We will shortly see how. So first of all, to locate its position, we will make two independent equations, one in x, the other in y. So let's start with that. Let's first analyze the x direction. Along the x direction, we know the initial velocity and the acceleration. The time is also given to us as 10 seconds. So clearly we can use the second equation of motion. Now, the second equation of motion is s is equal to ut plus at square by 2. So since we are solving this along x, let's write some subscripts to denote that we are talking about x. So I will write sx is equal to ux plus axt square by 2. This subscript x is there only to denote that we are talking about the x dimension. Right. So now let's substitute values. This tells us that sx is equal to ux is 5, so 5 into 10 since the time is 10, plus ax is given to be 2, so this becomes 2 by 2 into t squared, where t is 10 seconds, so this is 100. So we finally see that sx is equal to 50 plus 100, which is 150. So this displacement of 150, what does this tell us? This tells us that along the x-axis, the particle has moved up to a distance of 150 meters. So by solving this, we have determined that at t equal to 10, the x-coordinate of this particle is 150. So this is what we have found so far. Right. I'm sure you already guessed it. What is to be done next? We would write the same equation for y. In case of y, we'll write sy is equal to uyt plus ay t square by 2. In this case, we were given that acceleration along y is 0, hence this term goes to 0. Substituting the remaining values, you see that sy is equal to 10, which is the speed, into the time, which is 10 again. So sy, displacement along y, is 100. So once again, this tells us that the particle has moved 100 units along the y-axis. So let's again locate the point. So as you move 100 along y, you'll get a point somewhere there. So this is 100. Now, we know that at the final instance of t equal to 10 seconds, the particle has its x coordinate as 150 and the y coordinate as 100. Now to locate this point, and this is slightly mathematical, what we will do is draw a vertical line at x equal to 150. This is because this entire line has the x coordinate 150. As you move on this vertical line, the x coordinate remains 150, only the y coordinate changes. So this entire line is x equal to 150. Similarly, we will draw a horizontal line at y equal to 100 because this entire horizontal line is y equal to 100. On this line, only the x coordinate changes, not the y coordinate. Right. So the point of intersection of these two lines, must be such that x is 150 and y is 100, and hence that is the desired point. So this point which has coordinates 150, 100 is the point that we are trying to locate, and we can say that after 10 seconds the particle must have reached this point. Now that we have the result, try to understand how these two dimensions superimpose. There is a motion along x, there is a motion along y, but the particle is exhibiting a combined motion of these two. So the particle never actually moves along x, never moves along y. In fact, its path would be something like this. It would have traced a path like this. So this is the path along which the particle has moved. But we are viewing this combined motion as two independent motions, one along x, the other along y. And such analysis really simplifies analyzing such situations. Right. So whenever we have two-dimensional motion, it is very much same as one-dimensional motion in the sense that two-dimensional motion is only two independent one-dimensional motions. Right? That is exactly what we did. We broke the motion into two single one-dimensional motions and then combined the results that we obtained. Right. So now let's first understand motion under gravity, and then we will do a few more problems based on two-dimensional motion.